Hi, my name is Mike Della Selva, and we are going to talk today about pH and pKa. The main part of the discussion will be how to convert from pH to H plus, POH, and OH minus concentration using a visual chart. The visual chart is right up here, and I'm going to walk you through how you use this visual chart, and then we're going to go walk through some problems. So the first thing we want to do is look at what this means. So this visual chart really is, at this point, the hydrogen ion concentration, or hydronium, depending on what your instructor calls it. If you were to try to find the pH, you just follow the arrow, and this is the pH, and this is the equation, minus the log of the hydrogen ion concentration. Vice versa, if you had the pH and you wanted to find the hydrogen ion concentration, you would go this way, and it'd be 10 to the minus pH. Now let's try something a little more complicated. Suppose we had the hydrogen ion concentration, but we wanted to find the POH. Well, there's two ways to go. You can go this way to get the pH, and then this way to get the POH. Hang on one second. That's one way. This way, you could do it this way. You could go get the OH minus by using this equation, and to get the POH minus the log of OH minus. So this is a nice pictorial of how to solve problems without having to, I wouldn't say memorize each equation, but without having to possibly get confused. So let's do a couple of problems and see how this works. Okay, here are three examples, and we're going to talk about each one. So example one, if the hydrogen ion concentration is 3.2 times 10 to the minus 5 moles per liter, what are the pH and POH? Well, if we go back to the diagram, we have two ways to do it. So let's talk about path 1 and path 2. Path 1 takes us to the OH minus, and then to the POH, and then to the pH. So let's do this, okay? So excuse me. Go back to this one. So what we want to do is go from H plus to OH minus, and we use that first part of the equation, 1 times 10 to the minus 14th divided by OH minus, and then we calculate the POH by getting the log of this value, and that's how we get that. Now, if we want to get the pH, we just go 14 minus pH. Okay. The other way, which is a lot quicker, is you go to the H plus concentration, and I won't say a lot quicker, similar. You get the pH, and then, that's 14 minus pH gives you the POH. So either way works. Whatever way you're most comfortable with is how to do it. Okay, now let's talk about the second problem. Second problem is, what value of H plus corresponds to a pH of 8.14? This is pretty direct. Again, going back to the chart, we have this value, and we want to find this. Okay, so, my mistake. We have a pH value of 8.14, and we want to find the H plus concentration. So we have the pH. To get the H plus, we go 10 to the minus pH, and that gives us that value. Now, the third problem, again, these are very straightforward. What is the pH of a sodium hydroxide solution in which the hydroxide ion concentration is 0.0026? Okay, again, we have choices. Okay, but one of the things we need to do is to convert the 0.0026 into scientific notation. Otherwise, I think it'll be more difficult than than it should be. So, using the H plus path, and we have OH minus. So if we do this, 1 times 10 to the minus 14th over the OH minus concentration of 0.0026, or 2.6 times 10 to the minus 3, you get 3.84 times 10 to the minus 12. Then the pH is going to be this value minus the log, which is going to be 11.41. Then the other approach is to calculate the pOH and get the pH. So in this case, we have the OH minus concentration, which is 2.6 times 10 to the minus 3. And then we go and put it into this equation, minus the log. That gives you a pOH of 2.59. And then you would subtract that to get the appropriate answer of, hang on one second. Oh, I'm trying to do it in my head, but it's going to be 11.41. Okay, and that's how you do that one. Now, the next section, we have various problems, so you can practice on. They are highlighted in red. I'm going to state the problem, and then you can work to get the answers. First one is, what is the pH of an aqueous solution at 25 degrees centigrade that contains 3.98 times 10 to the minus 9 hydronium ions? This is the answer. Next one is, what's the pOH of an aqueous solution that contains 3.98 times 10 to the minus 9 hydronium ions? Okay, that's the answer. Number 10, what is the pH of an aqueous solution at 25 degrees centigrade that contains 3.98 times 10 to the minus 9 hydroxide? You notice how subtle but significant difference, because you're saying, well, these are all the same problems. No, they're a little different. Next one, what is the pOH of an aqueous solution at 25 degrees centigrade that contains 3.98 times 10 to the minus 9 hydroxide? And then the last one, calculate the concentration of hydronium ions in a solution at 25 degrees centigrade with a pOH of 4.223. Okay, and they want concentration, so you're going to have to do a two-step. That's all that you need to know to solve not pH problems, but to do pH conversions into, again, hydrogen ions, pOH, OH minus, or vice versa, or whatever you have. So the next problem, hang on a second, we want to do the same thing. We have a companion document, Ka, which works the same way. So why don't you just look at this for a few seconds, and you can see how everything is the same thing, except instead of H plus, you have Ka. Instead of pH, you have pKa. Instead of OH minus, you have Kb. And instead of pOH, you have pKb. Otherwise, they follow the same sequence of how to solve them. So I'm going to do a couple of problems and give you like 30 seconds just to digest this, or to take a screenshot, or whatever makes the most sense for you. Again, in this case, we're just trying to find the basic conversion between Ka, pKa, Kb, and pKb. Okay, now let's go to the next. Okay, again, to do this one, they gave us 5 times 10 to the minus 5th is Ka. So how do we find pKa? Well, we go back to the chart. right here. And you have the Ka value, and you go to get the pKa. Okay, in problem 2, they gave you Ka, but they want you to find pKb. So you're going to have to do, you have 2 paths. I'm just going to pick one. In this path, I want to find pKa, so I can take the value of 1.76 times 10 to the minus 4th, put it in here. I get a pKa value of 3.75. Then to get pKb, I subtract that from 14. Again, following the arrow, I get 10.25. So again, this is how I recommend you do it. I mean, you can do it other ways. There's no wrong way to do this. Just make sure you're consistent with how you do it. And then we'll give you 4 problems. I'm going to read them to you. The first one is the ionization constant Ka for benzoic acid is 6.28 times 10 to the minus 5. What is the pKa? Again, same way. The answers are highlighted. Hydrazine is a chemical base, and the value of constant Kb is 1.7 times 10 to the minus 6. What is the value for pKb? Again, very straightforward. 14, hypochlorous acid has a pKa value of 7.82. What is the value of the ionization constant for hypochlorous acid? This is it right here. And the last one, benzoic acid, has an ionization constant with a value of Ka equals 6.4 times 10 to the minus 5. Calculated the value of pKb for the conjugate base, and this is the answer. And that's pretty much it for this session. Again, if you need any assistance and you have problems, please either come to the ASC or attend some of our virtual sessions with one of our tutors. Again, thank you very much.